an integer and a continuous value is very, very small, right? So we get a very good approximation just by saying, okay, we'll solve the continuous variables and then just round to the nearest ballpoint pen. That's okay. If you're making aircraft carriers, that's probably not okay. In intermediate cases where you're making things that are substantial, like cars, where you really, fractional rounding of a car might be kind of an expensive thing. But we're really talking about time averages here, right? So this is average, maybe average weekly production. So you could imagine that we're some weeks making a full car, and the next week we're making no car, and the average is a half. Okay? Okay? Any other questions like that? Okay. Good. So let's talk about solving these kinds of problems. Integer programs, just as this is kind of an interesting observation, integer programs are just linear programming models that have extra constraints on the variables, right? We make them integer valued. If you have a decision to make, so you've got a bunch of choices in your life to make, about what to do once you graduate and stuff like that. If you've already signed a contract saying that you're going to serve in the Navy for 4 years, that makes your decision easier, right? I mean, because you have less choice. So you would think that the same thing would be true in integer programming, right? That we would have an easier time of making a decision once we recognized that we had extra constraints. Because the feasible region is going to shrink. There are less possibilities. But it turns out that we actually have a harder time from a computational perspective. And the reason really is that though the feasible region gets smaller through the addition of integer constraints, we lose all kinds of nice properties associated with linear programming. So linear programming has a great deal of smoothness associated with it and convexity, and all of that gets lost when we move to integer programming. So here's a picture that kind of gives you an idea of what the difficulty is. So let's imagine that we have an integer program, and I've plotted. You see all the dark circles here, big circles. All of those, including this blue one, are the feasible region for the integer program. That's what the integer programming feasible region looks like. It's a set of points. Okay, so it's far less in terms of the number of points than a linear program. In fact, the green region here that's shown is the LP relaxation of this integer program. How many feasible points are in the green region?